Second thing in Unit 3 that we looked at was standard form. Now, writing numbers in standard form is super useful, particularly for me in physics, because standard form is a way that we can write numbers which are either really, really, really big or really, really, really small. And in physics, we do tend to deal with both of those types of numbers. So if we're dealing with like distances in space, they're obviously really, really big numbers, and we don't want to be sitting writing zeros all day. Or if we're dealing with the size of an atom, or like the radius of the nucleus in an atom, that's obviously a really tiny number. And again, we don't want to be sitting writing not for ages. So it's a really useful way of writing small numbers or really big numbers. So we need to be able to change what I would call ordinary numbers. The proper name for ordinary numbers is decimal numbers. We need to be able to change from those into standard form, and then we need to be able to change back from standard form into an ordinary number. Okay, so let's get going on that. Flip me year 9. I forgot to even tell you what a number in standard form is. So a number, if it's written in standard form, has to have these two parts, and they must be true. So it must first of all be a number that is between 1 and 10, and then that number is getting multiplied by a power of 10. Okay, now I've said here we are converting ordinary numbers into standard form. Remember, ordinary really just means decimal numbers, and the way I've written these are both decimal numbers. Okay, now whenever we're doing this work with standard form, it's all about seeing how many places the decimal point has moved so that we can write the number as a number between 1 and 10. So we've got, first of all, this big number here. Now, because there's no numbers after the decimal point, we haven't written the decimal point in. That's just not what we do. So the decimal point here is here. It's just that if there's nothing after it, we don't tend to write it in. So if I was to write this number as a number between 1 and 10, which is multiplied by a power of 10, then my decimal point would have to be here to make this be 3.97. Okay, so once I've figured that out, then I look to see, right, well, how many places would my decimal point have to move in order for it to be here? And that's the power that goes on the 10. So this one is going to be 3.97 times 10 to the power of something, and we figure that out by seeing how many places this decimal point has moved to get from here to here. So it started here, then it went 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So 3.97 times 10 to the 9. Okay. Second one, we've gone for a little small number this time, so 0.0004021. Again, we think, right, if I'm writing this as a number between 1 and 10, where does my decimal point have to go? It has to be here, so that would be 4.021. So 4.021 multiplied by 10 to the power of something, and again we just need to look and see how many places it's moved. So 1, 2, 3, 4, 5, so times 10 to the power of, now it's not to the power of 5, it's to the power of -5. So if we compare these two, this one was a really big number and it's a positive power. This one was a really small number and it's a negative power. And do you see how my decimal point has moved opposite directions both those times? So here it was moving to the left and it was a positive power. Here it was moving to the right and it was a negative power. Now I don't really like using that left and right rule because I think I would get mixed up with it. So for now, I think the best way for you to decide whether it's a positive power or a negative power is to think about what the original number was. So if it was a really big number, it's going to be a positive power. If it was a really small number, it's going to be a negative power. Okay, so let's now look going the other way around. Okay, so going the other way around then, converting standard form into decimal numbers. So we just have to do the opposite thing. We look at the power and we move the decimal point that many places. So for this one here, 2.04 times 10 to the 9, I write out the 2.04 but without the decimal point in it. Okay, so 204, and then I take my decimal point from its original place and I move it 9 places. Now because this is a positive power, then it's a big number, so I know this is going to end up being a big number, so I'm going to be adding zeros on here. So my original decimal point was here, and I am moving it 1, 2, 3, 4, 5, 6, 7, 8, 9 places. Then I just need to put the zeros in. Now, I never trust myself with these questions that I've done it right, so I always take my big number and then do what I did up here with it and go backwards and check that it works. So my decimal point in my normal numbers here, if I go 1, 2, 3, 4, 5, 6, 7, 8, 9, yep, that gives me 2.04 times 10 to the 9, which is what I had. Now, with ones like this, 3.1 times 10 to the minus 7, automatically I'm thinking, right, well this is a wee tiny number because it's a negative power. So I don't start writing my 3 and my 1 here, I write it over here because I know I'm going to end up putting zeros in here before my decimal point, so I leave myself plenty of room to do that. So my decimal point was originally here and I have to move it 7 places, so 1, 2, 3, 4, 5, 6, 7. It's going to be here, and put my zeros in. So check it. 1, 2, 3, 4, 5, 6, 7. That's me, happy enough. Okay, so that is standard form. See you next one.